Welcome to qnawire.
Okay, first off, I just want to say that the picture did not upload, so I don't actually see the alkene that they're talking about. So I'm just going to draw a general alkene, and then we'll show how that will react with acidic water to form an alcohol. So hopefully you'll see how to apply this to your own specific example. So here's an alkene, and I'm going to draw acidic water, or hydronium, H3O+. So the first thing that will happen in this mechanism is that the double bond will swing open to grab a proton, like so. And the electrons that are between the proton and the rest of the water, namely the oxygen, will go on to the oxygen. The product of this will be that one side of this double bond gets a proton, arbitrarily choosing the left-hand side here, whereas the other side will get a positive charge. Okay. And then we'll also be left with our water that we generated from our hydronium in the last step, so OH2. And the next step is that a lone pair on this oxygen will attack the carbocation. And we'll move down here to finish, get a little more space. At this point, I'm going to stop drawing the hydrogen that we added, but I will draw the water. And I'm going to draw both of these protons for the time being, and also recall that this is an oxygen with 3 bonds, so it has a positive charge. And the final step is that we draw an additional water molecule, because we can assume that if we're performing this reaction in acidic water, there's plenty of water molecules around to participate in the reaction. And the final step is that one of these water molecules will take a proton from this protonated alcohol. It'll grab that proton, and the electrons that form the bond between the oxygen and proton will remain on the oxygen of the alcohol to give a final product of this alcohol, as well as note that we had water here and that we protonated it, so that one of our final products is going to be hydronium, H3O+. Also note that we started with hydronium and we ended with hydronium, which is why we often refer to this being an acid catalyst, because we've regenerated it by the end of the reaction. And that's what catalysis is all about. One of the points of catalysis. It makes a reaction easier and also is not consumed during the reaction. So hopefully you'll see how to apply that to your own alkene.